now. This is the basis of quantum computers. So we build things that rely on this effect. ER is Einstein-Rosen, which is Einstein-Rosen bridge, which is Wormhole. So they also published a paper about wormholes, Einstein and Rosen, in the 30s. And so the idea is that you could picture that somehow as being a kind of wormhole that connects the entangled particles. So that's how this entanglement works. Another description of quantum entanglement is a wormhole kind of geometry. And this is part of the cutting edge of research into black holes, but also the structure of space and time and quantum entanglement and how quantum entanglement might produce space and time. And it's related to the way that quantum computers work. So it's become a really hot topic because people are trying to build quantum computers and program quantum computers. And these are the kind of problems you have to face about quantum entanglement and how you maintain it and what it means. And there was a paper recently, which is quite a controversial paper, but that I think was the Google quantum computer, which is one of the best ones. And it's not using it as a computer. It's using it just as these qubits, these little quantum systems that are kind of very stable, that are the basis of quantum computing. And it's using those qubits and setting them up in such a way that something that looks like a kind of a wormhole is created in the quantum computer. It's kind of a one-dimensional wormhole, and it's a bit kind of technical and everything. But it looks like it might be the first hint of how you build space from qubits. And so so that paper was published. There it is. That's it, a holographic wormhole. It's important to say that wormhole, it's what's called a hologram. It's not really in our universe. It's kind of a different thing. Because that's the last thing I'll say, because I've got to blow your mind, because your mind looks...
It's
so
blown.
These theories, the hologram thing is quite well established now. And it's coming from a thing that you may have talked about with other people on the show, the ADS-CFT conjecture, a great physicist called Maldacena. So the idea is that you can have a quantum theory living on a boundary. So you could picture a sphere with a quantum theory living on the surface. And that there's a completely equivalent description of whatever's going on, the physics, in the interior of the sphere. So it's almost as if the interior of the space is a hologram of the theory that lives on the surface. And it's kind of not accepted